Good morning, chat. Welcome in. My name is Penbu. I am the programming, music making, and I got the order wrong. Puzzle gaming and music making VTuber on Linux. And today we are doing programming. If you were here last week, we were working on an esoteric programming language that I had come up with, based on Jelly Hoshiumi's, Jelly Hoshiumi in general, her catchphrase awawawa. Jelly Hoshiumi from Phase Connect, and we had gotten so far as to translate this BF string to awafudge, this here. Although there's a little bit of a bug, so we're going to fix that first, and then we're going to spend hopefully the rest of the stream translating it back. So from this to this. We're not going to be done after that, but I think that should fill most of the stream. So for this, if you didn't catch it from last week, we are using this tool called Json. It is a JavaScript port of the tool Bison, which itself is based on an earlier tool called Yak, Y-A-C-C, and yet another compiler. And we can use this to do lexing and parsing. Here it's lexing, where we read in its string and then return tokens. And then we have the parsing portion, where we take the tokens and parse them out. And in our case, we're doing actions based on it, so we're doing the translation on the fly while we're doing the parsing. To be honest, half of the stream last week was just fighting with the tool and trying to figure out how it works, because I've never used it before. But now I think I have a better idea of how to use it, and then what to do to fix what we have here. So to go over the bug. So there are two things here. One is that you see all this output where we have states with conflicts. Conflict and grammar, multiple actions possible, and look ahead token is whatever. And this is because the grammar is ambiguous, which means that we can parse a certain string in multiple ways. In this case, operations here could be, say, an increment followed by an increment, or it can be a single operation with just a bunch of increments. And we don't want to do that. And then the second one is that when we have, it was P. What do we have set up here? P, yes. So we have P as our parse function. It translates it to awawawa. But we also get the same output when we have this here, which is not what we want. We actually want spaces like that, because otherwise it's ambiguous. You don't know. This would otherwise translate back to this, but that's not what we have here. We want to add spaces here just to make sure that we have things that are separated. And so we're going to deal with both of those first, and then we can go ahead with creating the JSON file for the other direction. So it was suggested to me last time that we could maybe handle the repeats during lex time. So we can provide a regex here to say that instead of having a single character here, we do multiple characters. So that's the one solution for this. And the other solution for the other bug is to, I think it's just as simple as adding spaces. So why don't we start with that first? I wish we had written tests last time. We did not. So I'm just going to have to trust that this works. We just had a bunch of spaces here. Because the only parts that we need spaces for are these four. And the rest of them are punctuation. And that's not entirely true. Actually, no, that's still true here, because we still want the spaces there. So we have the spaces here, but that if we start with one of these, we'll have a space at the beginning. And so what we can do is then we can trim it at the end. And all of this stuff in here in brackets is all JavaScript, so we can use any any JavaScript function. So in this case, we have the trim function from the string prototype. And let's hope this just works. Very good. Very good. And then just a bunch more here. That looks a lot more correct, yes. We have 4 was, and then a wa for that. These was, wa for that, and then the loop for that. Yes, I think this is good. So going over the language again. So we have the base mapping from BF to awafudge, and we're saying that every wa is a repetition of the character. So in this case, if we have, going back to this, 4 pluses, and we have our base mapping as for plus being awa, and we repeat the wa 4 times. So wa, 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 wa. This is good enough for commit, so we will do that. Okay, that's both of them. Add spaces between non-punctuation. No, that's not right. Add space between. Sure. Runs. Let's go with that. I actually need to amend that. Spaces are necessary to avoid ambiguous output, such as plus, minus, minus, and so there are specific ones actually. So we have plus, minus, plus left shift, and minus left shift. Plus left and minus left. Such as 4 combinations. Okay, so now we have a commit. And now we can solve the other problem. So we're going to start with pluses first so that we can prove that it works. So instead of a plus here, we turn this into a regex where we have a literal plus followed by, we'll repeat 1 or more pluses. We return pluses or increments. And so we replace this with increments. I did not need to delete the whole thing, we just add an S here. And it was said that we do have, there's this variable called yylen, which apparently isn't in here, but it is in Bison. So yylen gives us the length of the string, in which case, for us, it gives us the number of pluses that are in the token. And we have mdn string.prototype.repeats. Make that a little bit bigger for you. The repeat method of the string values constructs and returns a new string that contains a number of copies of the string concatenated together. So, in this case, we have ABC repeat. I guess in our case 2. We get ABC ABC, which means if we do it with wa dot repeat and then we say 4, then we get wa 4 times. By the way, if I'm going too fast, let me know and I can slow down. And so that's what we want. That's what we want to do here. We want to repeat wa 4 times, or length times rather. And so this should make our grammar unambiguous, because we won't have an operation followed by another operation of the same type. It's only ever going to be what do we have here? Well, actually, it might be a little bit, but we'll see. But hopefully it's only ever going to be just this. You know what? It might still be ambiguous. But we'll see. I need to save that. But first, does it work? Uncaught reference error, increments is not defined. Because I need to turn this into a string. Okay. So it looks like we still preserved it. So we can do that for the rest of these. Change the plus into an S. And just the first pluses. And then we can do the same for these ones. So we can take off this. Escape these. Do the same for this one. Oh, I still need that minus. We can add the pluses there. Nope. Plus, 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 and then plus. Actually, I might not need it for this one. I think you only ever have the one. So this one might be okay. Because input and output can be the same. So this we can keep the same. And then this you're never going to have more than one, I think, that we have to deal with, because they're all just going to be loops, so this can stay the same. It's only these ones that we care about. So that's decrements, left shifts, and oh, after that, right shifts. So inputs, outputs, and the default for this one is actually $$ equals $1. So we don't need to deal with that. That can stay the same. And I think this needs plus. I think this is probably okay. Which means actually we don't need these anymore. And let's have a look if that still works. Could not parse JSON grammar. Why? Probably messed up somewhere. Return decrements, return increments. We need to escape this. It wouldn't hurt to escape it, I guess. Yes, that was it. Join is not a function. Why? Where is this? Okay, so what if we kept this as it was before? We can always change it afterwards. And then we need this, that, still. Try again. Unexpected identifier S because it's a little bit too greedy. Okay. We need to change all these to was. But other than that, we still have some conflicts. Because input and outputs... right, we kept that in as that. Because we have push $1 for operations, push $2 for operation. Which should be fine because $1 is a string. So actually if we remove this, it should still be okay. I have a feeling that's not quite going to work. Because it says join is not a function. Okay, so we'll leave the grammar ambiguous. We'll try to deal with this one first. So everything that is $1 dot join, we change that to y.repeat yylen. And hopefully this still works. Nope. Parser error. Expected right shifts. Typo. Try again. Okay, so that looks correct, I think. So we have that, and then now we can just make this. Well, I'm trying to figure out what's wrong with this one. So input is that, output is that. We do this and just make it $1. Don't rely on anything explicit. But that's not the problem, I think. I think it's, we need to get it to join with something. Join. But this is already an array because this is empty. I don't see any other joins. $2.join. But this is an operation, so that should be an array already. Oh, maybe it was fine. Oh, whatever. Okay, so now we've made it unambiguous, and we have the spaces, so we can, I think that's that for that one. So we can commit that. Make grammar unambiguous. Handle repeats during Lex phase. Sure. So now we take this and then we do it the other way. We try out parse out the awas and turn them into BF symbols. This one's probably going to be a little bit more complicated. So where are we? Make a new folder. Awa to BF. Making a file, awafudge.json. And we can copy this over as a template. And then we're going to change it up a little bit. We're going to ignore anything that is not a space, an A, a W, or a tilde, or dot, comma, question mark, exclamation mark, because those are the characters that we care about. It's not quite this. I think. Actually, no, this is correct. That's not quite correct. It's either anything that's a space or not one of these. And this is actually going to be considered a space. We're going to consider that a space. And then anything else, we have starting with let's recognize one thing first. Recognize wa. And then we'll leave the rest for that. EOF is EOF, just so that we have stuff. So operations, EOF, I think this can stay as is. And then this can stay as is as well. Probably. And then an operation, we start off with nothing. So an operation can be a decrement, in this case. One or more decrements. But what does this get us? So we'll turn that into a minus. So actually a decrement can be, or what's called as decrements. Instead of uppercase, we make this lowercase. This uppercase, the convention is that terminal ones are uppercase, but not non-terminals. The decrements is not a terminal because we have more to go for it. So we have decrements is a string of wads, more than one. So that is equal to the length and we repeat minus for that length. Because 1 here is an array, and we get the length of the array, and so we can repeat minus for that many times. And then, so that's decrements. I think we can start with that and see how it fits here. This is now awafudge. This is also awafudge. Could not parse JSON grammar, of course. Where do we mess up? So operations is here. Operations, operation. Operation is decrements. Is this? Decrements is awawawa plus. This should be uppercase. Still no. Does this need to be double? No, these are just single. Can anyone spot the bug here? I'm having a little bit of trouble. So this is a regex. And what if we don't do this? What if we don't do that for now? We don't have any spaces anyway. Okay, so that's not the problem. So our decrements, decrement while plus, EBNF is enabled, so we can use the plus here. We're repeating this and $1.length. Could not parse JSON grammar, process grammar is. So something about this is wrong. When we compare it to this, that all looks mostly the same. Is it this? Can we not do that? No, that's not the issue. And everything down here looks to be correct, or the same anyway. Operations, operation, that, operation is that, decrements is what, plus. And this is the same. That is the same as up there. What if we remove this? You have the semicolon. Aha, you do not have the semicolon. Missing semicolon. So now we have more conflicts. Decrements could be decrements. Because of this. Makes sense. We can leave that for now. We can figure out how to disambiguate it later. So, we're looking at a string of was. And we do one. And we do multiple ones. No. Lexical error on line 1, unrecognized text. Why is that? Text is the empty string because we have run out of was to go through. Can it handle 2? It cannot handle 2. I thought this was supposed to be 1 or more. Should be. What if we do that? Okay, that's already wrong. $1.length, because this would have been a plus. One, two, parse error. So at 115. Not that one, this one. 115. New error. 265. 265. Parse error. Sure. Object next, lex. 152. Token stack. Parse. So earlier we weren't having this issue before because we're only working with single characters, but now we're working with multi-character tokens. Is this not a thing you can do? No, that's still not it. So it says text is the empty string, but I thought we had covered it with the EOF. Okay, so what if we recognize empty string and just return nothing? No, that's not quite right either. So, is this half of the stream going to be fighting Jason again? It might be. Token null line 0. So what if we do awawawa here? I'm gonna copy this actually. And then just hardcode this for the time being so that we can see what happens here. The case, and so if the problem is lexing, then this shouldn't matter. Which presumably it is. It's unrecognized text. Another JSON. Lexing. Within Lexer actions, use that delimiter if you want to use block style statements. Within parser actions, we alternatively use double braces for delimiters of the same purpose. We don't care about that. Lex patterns, literal tokens. Easy keywords. Notice that token foo will match whole word only. Oh, because whole word, okay. Maybe that's why. Because it's only whole word. Which means this does not work. Because it's whole word only. So if we want it not to be whole words, then we put it in parentheses. There we go, that's what we want. Yeah, add more, we get more. Nice. That's good enough for commit. What is this? Transfile, awafudge decrement. Okay. And we may as well take a look at this, because that's a space too. That is probably not going to be recognized because we don't have any rules for it. Okay. Which is fine. So now we can do the same thing for So we can do the same thing for increments. $1. Increments is an app followed by multiple watts. Equals plus dot repeat $1 dot length. Same thing here. And we should probably add semicolons inside as well. So now we should expect to see this, which is not correct. Why is that not correct? But this still works, hopefully. Ah, right, because we have $1, this should be $2. So $1 is this token, $2 is this token. So we actually want $2 to get the second one. There we go, that's what I want. And then we also want to be able to recognize this, which we can't because we need spaces. And how do we differentiate between these? Because we can't have operations. So we can do one operation, or we can have operations. We have operation, operations, operation. I think. So either we have empty, we have one, or we have two or more. And so this case we have just the one. So this now becomes 2 because we moved everything over. This is 3, this is 2. And we also need single operation $2 dot unshift $1. I think it might be better actually if we do it differently, because we can start with an array, We can push $2 or $1 actually. Let's not do that. Yeah, let's stick with that for now. We can clean that up later. What I was thinking of, we would start with a fresh array and then push this one, and then concatenate this one, and then push that one. I'm trying to avoid the spread syntax because, well, I suppose it's not entirely necessary to do so. But just to keep things compatible. Nice, and of course we get conflicts. Which is unsurprising. This doesn't actually help us, because so what we need is we need to figure out where to put the space. And I'm hoping we don't have to blow this up. So what do we actually have? So if it's an increment or a decrement, we need to have a space in between. So we might actually have to split this up. So the only times we actually need a space, if we go back to the spec here, are these three combinations. The plus minus, plus left shift, and minus left shift. So increment followed by decrement, a increment followed by a left shift, or a decrement followed by a left shift. So we might have to do something around that. I'm a little bit lost here. So if we can't do simple operations like that, then we can have space required operations. And then that would be either increments, base decrements. And so far that's the only one that we have. So we can do this. $1 plus $2. Because we don't actually care about the space in this case, for the eventual only for the BF source. The BF doesn't care about anything other than the characters, so we don't actually need to add any spaces there. Well, we do care about it for awafudge because otherwise it would be ambiguous. So the space required operations is this. Now, how do we make that not ambiguous? We have operation here. And maybe we actually don't do this one. Maybe we don't do an operation. So it's either we have an operation, or we have an operation. So here's a tricky bit, because we need to make sure that we can describe strings that have increments, like only increments and then only decrements, but also increments and space, the increments followed by decrements, but also decrements followed by increments. And so what's the best way to do that? We have EBNF on our side, actually. EBNF. This might make things a little bit easier because we do have the groupings available to us. Like so. So what we can maybe do is do something like space required operations, or okay, so we might have to do or space required operations. We'll start with this. What's $1? We'll maybe comment this one out. So right now we have an operation, which is just $1 in an array. So an operation, or we have our case of 2 operations. Is that correct? So, or non-space or space not required operations. $$ equals $1. This is also actually $1 for now. We have described a grammar where we have 1 operation, 2 operations where space is required, and operations, or 2 operations where space is not required. Space not required operations is, say, one of these is decrements, and then increments. Call that space optional, actually. Because we can have a space, but it doesn't have to be there. Same thing here. This is going to be $$ equals $1 plus $2. And then we need our semicolon there. So we have described a grammar where we have 1 operation, and then, or where we recognize strings with 1 operation, no operations, 1. Oh, actually no, this does need to be in an array because we join it at the end. So 1 operation, 0 operations, 1 operations, and 2 operations, 1 with the space required in between, and then 1 where the space is optional. So we're going to start with that. Yes. So let's first go with a single case, multiple. Okay, that breaks. But, well, that one's weird. We go for that case, and this is not what we want. What's happening here? So we have, the first part is being recognized, but not the second part. And the second part is not being recognized because it's a space. We actually need not at, we need $3, not $2. There we go, that's what we want. Okay, great. So I think that's worthy of a commit. And then just for, yes. We can solve that afterwards as well. Recognize plus minus and minus plus combinations. So this might be... No, we're still missing some, because now we can't... So we have this, but we can't recognize another one like that. Because we only recognize up to 2. Now we need 3 or more. And this is where it gets a little bit tricky, because we need to say that if the previous one is increments and the next one's decrements, we have to make sure that we have a space in between. So I don't know if this is what's going to cut it. It probably isn't. So, going back again to what we have here, we have plus minus, plus left, and minus left. So we have plus minus grammar. See, I remember writing grammars back in university, but no, this one's eluding me a little bit. So I have to come up with a way that we can describe, as long as you have a plus. Oh. Is it... No, because I don't think we have look behind. We don't have a look behind, so, well, we kind of do. Because we have $0. Our $0 is somewhere. I don't remember where it is in this one. Semantic actions, braces, shorthand syntax, named references, actions, and locations. For use in here, variable $n acts like a variable, the actions, variable type else. Give me a moment, I'm just going to take a drink. Okay, now our macros acts like a structure variable containing information about textual location. Like structure variable containing information on textual location of the nth component of the current rule. That is not what we want. Okay, going to actions. Name references, name references. And with 0 or negative is allowed for references to tokens or groupings on the stack before those that match in the current rule. This is very risky practice, which is why I don't want to do this. Use it reliably, you must be certain of the context in which the rule is applied. Here's a case in which you can use this reliably. Expression bar plus expression, bar minus expression, bar empty, previous expression equals $0. As long as bar is only used in the fashion shown here, the $0 will always refer to the expression which precedes bar in the definition of proof. I don't think we want to rely on that. We gotta find a way that we can unambiguously determine what the... Is it determine what the previous one is, or do we say what the next one is? So if increments, space, decrements... This is tough. So we have... What do we have? We have 1. So this works for the case of 1. We have operations. Operation. This is what we had before. But this is not reliable because then we run into the issue where operation might be something else. Might be one of these, which actually we probably don't want. So what we can do, I think we can blow this up. We can blow this up to have... no, I think we can... I'm not even thinking straight anymore. We have the operation, which is one of these. We need to be able to describe a single operation. And then we need to be able to describe multiple operations, both even number and odd number. And I'm not sure we can use a loop like this. The thing is, you don't want to blow it up in such a way that you end up specifying all possible combinations, because that's not flexible. So how do we do this in a way that it's flexible? Anyone in chat can think of anything? Time to Google things. BNF grammar. What are we looking for? Repetition? Hopefully we can find something here. Is repetition expressed in Backus-Naur form by recursive, BNF gen, BNF notation syntax. eBNF and are equivalent. Right, so let me turn the script on. BNF gen. Random text generator based on context-free grammars. So that's taking BNF and then generating something. That might actually be useful at some point. But we're not going to need that now. This is a specification for BNF, which we don't need. How to denote at least one repetition. Place a minus except symbol after the brace, which in our case is represented by something else. My brain cell's on hiatus right now. Sorry, don't worry about it. Yeah. Also, welcome in. I'm sure we'll get this in by the end of the stream. That or we don't end the stream until we figure it out. One or the other. Okay, more searching. Syntactic equations. I think the problem here though is that I don't know how to word this precisely enough to get a search result. BNF. Productions, expressions. Maybe loop is going to be a lot easier to work with. But I don't want to continue developing this until we can figure this bit out. So this isn't empty, this is actually space question mark. Because it can have a space. And then this can be space operation. And then space. This becomes $2. This takes care of having spaces here. Like that. Expecting EOF awa got space. And yeah, of course this is all very ambiguous too, because we have space required and space optional here. Did I save? Why? Because we have an operation, this is correct. Expecting EOF, dot space, which should be fine. What if we do this? Put that up here, because maybe it matters a little bit. I know that when it's ambiguous, it actually does matter what the order is, but in this case, it should be fine. So the space empty, all spaces, we got nothing. The empty string is nothing. Wah. We broke even that. Because this isn't allowed? Well, okay, so we bring this back to where it was. $01 is not defined because this is now 1. When I would try to make a language, I would make a fourth clone. I haven't looked at fourth in a while. I don't remember what this looks like. Procedural stack. Yeah. Rosetta code. Oh, don't do that. Yeah, when was it when we did the so I took a programming languages course in university, and we our assignment series was based on writing a compiler for a stripped down C-like language. What are we looking at here? Fourth. Oh yeah, okay. Yeah, C is bread and butter. And the C syntax is surprisingly terse, or rather compact in terms of its grammar too. If you look at JSON and it's try, there's a try thing here. And they have an example for NCC, and all it is this, which is surprisingly short. Actually, wait a minute. No, this gives me an idea. Thanks for that. We can look at some of the stuff in here, because we do have examples that we can look at. It's already been written. The primary expression, postfix expression, argument list, unary expression. Maybe we can find something that's a little bit close to what we're looking for. Like the calculator. Maybe. These are all binary operations. Well, these are unary operations, sure. So you skip the white space. In our case, we kind of need the white space. On demand look ahead. What does this mean? Maybe this is Bison one. One of the things I don't like about this is that there's seemingly a lack of documentation, in part because it's so close to Flex and Bison. I think that's a combination that it just outsources the documentation of that, which, sure, I get it, but also it makes it hard to find things. Patterns. We don't need patterns. Let's go to table context. The contents. Options. Options. No, that is not what that has. What are we looking at? We are looking at options. Options are on-demand look-aheads. Maybe, we do npx JSON help. We will get something there. Of course you don't. You have more comprehensive documentation. I think these are the docs. Yeah, these are the docs. Option. Literal token. Under the hoods, longest rule matching, additions, using special characters, negative look-aheads, flex case insensitive. Can you give me a list of options, please? Okay. Kinda don't want to search the code for the all possible options. But also, maybe. Actually, we can just search for what this is, right? On-demand look-aheads. If true, only look-aheads in inadequate states are computed faster, larger table. If false, look-aheads for all reductions will be computed slower, smaller table. It doesn't really matter, I think. Well, it matters a little bit. Yeah, I don't think it particularly matters. I think that's an optimization technique. So we have dots. How does this handle spaces? What is all this? Alpha. Type. Yes, space quotes. We have left associativity for that. And then we have start expressions. So expression is a graph plus an EOF. And then the graph is a graph statement, ID statement, and then a list of statements enclosed in braces. We have strict, and then the same thing with a graph statement, and then with no ID. So where do you do all the spaces? You know what, I think... Okay, so let's simplify it a little bit for ourselves. And don't do this. No, we kind of need to enforce a space, though. We need to enforce a space on our side because we need to say that there has to be a space here. ID statement, text no tags, token plus equals dollar space, whatever. Statement list. The statements followed by a statement list. I thought this had to be left recursive. Interesting. Maybe let's try to find a smaller language. Flow? I don't know what this one is. It looks like it's pretty big. Right. And the last time I tried this, it hanged the tab. Because it was so large. Regex. I don't think this is what we're looking for either. with includes. Description, grammar showing the include feature in both Lexer and parser. I think we're okay. JS core. This one might help us a little bit. Non-associative if without else, and non-associative else. Sure. Literal. Ident. So that's a property, string, property list, primary expression, open brace, close brace, property list, close brace, or dangling comma. This token, an array literal is this. The element list, elision opt. This looks like a makefile. Like, kind of. Yeah, I guess it kind of looks like that because you have the indents here. Although these are spaces, not tabs. But yeah, I mean, it's structured similarly in that you have what do you call this? Like a property or some sort of identifier, and then the thing that describes it. It's almost so in a way it's almost like prologue, but not quite either that. For a makefile, these would be your commands. In prologue, these would be your sentences. No, I think the whole thing is a sentence. But these would be the parts. But yeah, something similar. So we have an element list, which is the list of elements here. We have an elision opt, which is an elision, which is a string of potential or like empty commas. Okay, so a bunch of commas and an assignment expression. Or we have an element list, which is one of these. Or we have an elision opt and another assignment expression. Okay. I am seeing that spaces aren't here. But also, I don't think this comes with a lexer. So it's kind of hard to say what these all mean, because there is no lexer. If we look at the C file, actually, maybe that'll be a little bit... Oh, this one doesn't come in with the lexer either. Oh, no, no, it doesn't. A token... Basic with lexer. Natural number. An expression. So this is a little bit too basic. Contains a nullable A non-terminal. So it's just a bunch of X's. This one's a large one too. Somewhere in the JSON there sits something that parses this file too, so it's so meta, mind blown. Yeah. File is all the way down. Comments. Parser for extracting comments out of a string. Lexical grammar. So you have a lexer here, a line end, comment name. What is this even? What? How does this fit into grammar? This looks very foreign to me. This doesn't look like anything I've seen in the other ones. Oh, I see. I don't really see, but okay. This is comments. I don't think these are the kind of comments that we want, though. Distant. I'm not familiar with this one. Add submults. Is some sort of assembly language? Looks like it. Well, I need lexers. Identifier, words, console log. Either I'm not looking hard enough, or not thoroughly enough, or they just actually don't have an example of how to do this. But I know that we have to have this because we need to specify that there is a space here. I think. Right? Surely. Because the NCC, like, there's nothing here that says space, right? Space. White space. Oh, there's nothing there. So what do we skip space, actually? What if we do that? What if we just don't do it? But then how do you say that there needs to be a space here? You can't. You kind of need that so that you can say that there is a space. Like, this will pass. But then unrecognized text because there's no character there that says spaces. But then actually we skip the spaces, so what's wrong? Does that mean our spaces are wrong? Or it can't be because it was working before. We had this one, patterns. An R, but only if it is followed by an S. Ooh. That might be interesting. R, but only in start condition S. How do you define a start condition? Character class, negating character class, any character except an uppercase or a new line, 0 more R's, regular expression, 0 more R's here, 0 or 1, sure, 2 to 5, 2 or more, 4, exactly. Expansion of the name, definition see below, literal string, because it has this. Okay, the quotes. If X is A, B, F, N, R, T, or V, then the ANCC interpretation of X, otherwise literal X. Sure. Zero null. Sure. Match our parentheses used to override precedence. Yes. Regular expressions listed above are grouped according to precedence, from highest precedence at the top, lowest at the bottom. These grouped together have equal precedence. For example, you have that. Okay, so this is valid. And this is doing what we want it to. Because anything that's not an A, W, tilde, dot, comma, question mark, exclamation mark, or any spaces, and we have any number of those. Will match a new line unless \n or equivalent escape sequence is one of the characters explicitly present in the negated character class. The rule can have at most one instance of trailing context. start condition EOF patterns can only occur at the beginning of a pattern. Slash and dollar cannot be grouped inside parentheses, which we don't care about. Okay, so the slash I think is our look behind. That's what that is. So I don't think there's anything wrong with this from what we had earlier. Let's change this back. So we do need a space, but it might be that we need the space down here in case order matters. Why only that? Because I do have space optional here. So that, I mean, that works as expected. Empty, bunch of spaces. Right, we still had this, which is probably not what we want. Right, because you want 0 or more spaces here, probably. Which means this is 1 or more space. Expecting EOF and space got A. Which makes sense because we have this. Still not right. And it is ambiguous, so you might need it to be at the start, like that. These are quite correct, but that makes sense because we don't actually have any recursive rules. Oh wait, this feels wrong though. I don't see any other grammars doing this, which is seemingly not correct. Oh, okay, no, I got it. So, operation. So we have, so we really only need, okay, so let's have a look at this. We have operation, so we have plus, space, or sorry, increments, space, decrements. We have, anything that's not an increment. So let's denote that by an exclamation mark. Increments, space, or not space, and then anything, or pretty much any operation. And then we have, so I think we just need to do it that way, don't we? In this case, it's increment space, either decrement or left shift or one of those. We have decrements, space, plus shift, and that's the third one. And then the rest of them can be anything that's not on increments. So anything that is in increments, and any operation that is not a decrement or left shift. And then we have decrement that is not a left shift. And then other than that, it's any other operation that is not increments or decrements. And then any other operation. So that, I think, fully describes it. I was hoping we wouldn't have to spell it all out like this, but we might have to. So if that's the case, then this is any operation. This is correct. So any single operation, or any operation naming. How do we name this? I don't want to name it that, but I guess we can change the name afterwards. So this is decrement. $1. An operation requires space. There a way you can say that? No, whatever. After decrement is left shift, which we don't have yet. But for now, we're going to keep it as that. Which is basically what we have here. This is increment space decrements. And then we follow it up by operations. No, this can't be right either. Is that right? No, because we can't have recursion. Because we can guarantee this portion, right? But if we turn this into a generic, say decrements and operations here, we can't guarantee that, because we need a space here. How do we add that space without blowing this up? All right, man, this is hard. So we have our space required operations, which may or may not be used. If we can. So I think we might end up. What was it? So this is actually space that. That makes it a little bit easier. So we have space plus decrements, or space plus left shift. Decrements with an S. operation requires space after increment. So I think we can do that. Hello? And then maybe we can move this over there for now. We still have the problem of how do we recurse? Because I don't think we can have a generic operations here. Or can we? I think for an increment actually we can. So we can have that. We can have any operations there. So this is our left recursion. We can start with that. So we have that. Oh, expecting EOF, I got a space. Why? Because you should be expecting decrements after that. The operation is because it's ambiguous, that's why. So if we got rid of... We can't really get rid of this though. We'll move this over to the end then. No, that's not it. The operation requires space after increment. We have space decrements. And then... Oh... Right, so if we get rid of this, then we only have that. Let's try that again. Why are you expecting EOF? Why do you not expect a space? Is it because of this? But then we cripple ourselves. But also it's not even working properly. There should be 2. It should be $1 dot concat dot push. No, let's do concat. So we can keep it there, right? Concat, what do we have? Increments $2, and then $3. And so this is actually $2. Okay, that's what we want. But now the problem is we lost this. So we can add this back, but then we're going to end up with an issue where, so we can recognize that, but we're going to fail on that. If we change the order, we're probably going to be not okay, I guess. What? How long have we been going for? 96 minutes. It's been an hour and a half. Okay. Operations increments. Operation requires space up increments. We have space decrements here. You see an increment. Expecting EOF got A, or EOF or A got space. But I told you that you can have that. So, I mean, you're clearly here, maybe. So text is space, token is space, line 0, first line, last line, first column, last column. Expected EOF for A, you got space. So what if we don't do this? What if we just leave it empty? And then it just works, because of course it does. But then this breaks. So empty or space plus. Something like that, where we just don't do anything at all. Actually, no, in this case, this is also just an empty array. Oh, look at that. That actually works. And what if we have multiple spaces here? Very good. This does not work with one. We still need the one operation. And this is not going to cut it, because now we have something where we can have a plus and then followed by a minus, because this allows us to do that. Actually, no, this is just a single operation. That might be fine. So with a single operation, I think it might be okay. Well, one. Okay. So we're okay for that. We're not okay with this one. But that's fine. I don't think we have a rule for that anyway. But then we broke this one, which was working earlier. Will this be fixed if we change the order? No. What is it about this one that just makes it fail? Unambiguous operation. In which case we don't have one right now, because we're only looking at plus and minus. So what if we don't have that? And what if we have this as optional? So this allows us to get increments. So that allows us that. That allows us this. Undefined. Again, okay. We have that. We do not have this because we don't have that yet. Can we do that? No, we can't do that. Okay. So we might end up having to actually blow this up and say that we might have to do all the transitions where we have increments and then followed by the other 6, 7, and do it like that. Surely there's got to be another way. So actually I'm gonna move this space plus outside. No, there's gotta be a different way to do this. So operation requires space after decrement, which doesn't exist yet because the thing. Space optional operation. Optional space after increments. Okay, so space that. This is just 3. And then we also have space star for decrements. No, that's not right. Because it has to be, yeah, so this is that. I think we have that. And it could be either or. There's gotta be a better name for this too. This is way too long. Okay, so that's fine. So either we have an operation that requires space after increments, or an operation with an optional space after increments. And then that is optional. So we can have this. Could not parse JSON grammar. Why? Do I need spaces? Oh, I accidentally closed that. Alright. Move this up. Gotta go back in there. Source awa to the F. We're back again, could not parse JSON grammar. Let's go back and find the EBNF syntax. Oh, you don't have OR, I see. That's why, because you don't have OR. Oh, you do. It's in there. How to befriend. Yes. Alternation within groups, it's in there. For parsers, or to be checked. I mean, I don't know what you're asking for, it's right there. I mean, okay, so if we can't do that, then we can do this. Do it the long way. Try again. Okay, that's not our issue. Something else. Yes, stray semicolon. There we go. It said space optional. Expecting space wa got ah. Okay. And what do you want? This is actually 2, not 3. Expecting space, wa got ah. But why? I gave you an OR here. Operation optional space after increment, which is another increment. Space star, which means 0 more spaces and then an increment. So you have operations increments. Alright, so you can still do this. Or we end up with an empty like that. So you have a bunch of spaces, and then you have increments, and then that works. Here out the space plus. Or you have the optional space, space star. We have increments. Increments is a wa and wa. Actually, these should be stars, or well, this should be a star rather. But we'll deal with that later. Okay, so what if we split this out? What if we split this out and do this? So now I can't complain about the alternation there, which I figured wouldn't actually help because it doesn't change anything. So what do you want? Next, A, token A, line 0, first line, last line, first column, last column, expected space or wow, why are you expecting that? What if we do that again and then change the order? Because it is ambiguous. And an order might matter. Apparently it doesn't, okay. That's fine. What if instead you do this? No, apparently that doesn't help either. Is it because of this here? No, because we don't even have a recursive. We don't have anything recursing on the right side. So we can have, if we have two of them, say we have space plus, and then we do one of these. So this is increments, let's say optional. So we do this grouping here, and then we do this grouping here. And then we do another grouping here, increment optional. Is that how it's trying to parse it? Because it's trying to do that. I guess it is. So actually, if we remove this, then it should just work. Do not parse Jason grammar. Wait, do I have? Oh, I do. Okay, great. Let's do that. No, even that doesn't help it. Why? Which kind of makes sense because we don't have it. Like, we don't have anything that has a space optional. Right? So on operations can either be empty spaces operation space plus. I think this is what's missing. $1. That's not quite right either. So what are our conflicts though? Operation repetition plus 0, looking at I have space A, and then operation repetition plus 0, operation repetition plus 0 space look ahead space. So what? Which kind of makes sense because of this. It's probably something to do with that. Because you have the space plus there. So what if we don't do that? What if we don't do that either? What if we just do it here? And make it simple. We have an operation. EOF. Return $1. Or it can be empty. We can start with that. Oh, that's quite right though. But at least this way we don't have to deal with single operations. Cannot parse Jason grammar. And again, I closed it. Gotta stop doing that. Whoa, could not No, no, right, because I'm not in the correct one. North. Now, of course, we got conflicts at the beginning too. And that still doesn't help. But at least a single case still works. Alright, so this is actually already handled. So it's either an operation, a single one, or multiple ones. Because the empty already handles it. That's why we had the conflict up there. Alright. Why are you still erroring? Do we need to give it an order? Probably not. That's not what the issue is. Expecting OF got space. So there's still just something wrong with the grammar. Still expecting OF got space. Because there's overlap. We don't want there to be overlap. I still don't think this is the correct move though, because we go back to what we had. A program is a string of operation. That is correct. It is a string of operation. And then what if we just don't deal with spaces? If we don't deal with this one for now, then that means that we can't recognize all the space at the beginning, which is fine. We also, can we deal with this? Because we can actually just lex that out. We can just lex that out. If we have this stuff beginning, we just don't deal with it. You know what, that might just be it. We just ignore it during lexing. And then maybe same thing with trailing spaces. Expecting space wa got ewa. Kinda makes sense. Well, that's not quite right, but at least it doesn't fail anymore. We have operations, that's 1, this is 2, this is 3. There's still 1, 2, 3. So if that's the case, then we don't need this anymore? Is that what it is? Or maybe we still do need it. Still not quite right. Space decrements 2, increments is a 1. This is actually a 1. Because there's nothing there anymore. Why are you still only getting the... So it's not picking up the decrement. It is not picking up the decrements. So this one requires space after increments. Sure. So I'm going to delete this because I don't think we need it. Why are our minuses not showing up? Because it's clearly being recognized at least. But anything after the space just doesn't... $sign equals $2. Decrements is the minuses. And then here... $3 is a string. Console.log $3 or $3. So we're gonna log this out and see what we get. Undefined. Well, that would certainly do it. Why is this undefined? Is it that? Does it just not recognize it? But then you would fail about parsing the rest of it. Because it needs it. Expecting space while I got EOF. Well, yes. I gave you the option of being empty. Why are you expecting a space afterwards? Because you got the space here, and then you got the decrements, which is a bunch of was. Is it because you're expecting either a space here or another increments? Is that what it is? Clearly not. You are getting you up, but that's... You aren't supposed to care. Why? So I have to say, the thumbnail for this stream is pretty fitting. I wasn't expecting it to fit so well, but let me pull that up if you haven't taken a look at it yet. It is this one. Yes. That is exactly how I'm feeling right now, and I don't understand why this isn't working. So we got $2. Why are you expecting a space while I got EOF? Where is this coming from? I wish it would tell me which state it was at, because then we can at least so 121. I guess it kind of does. Parse error. 622. That's too far. 188. Lexer, show position, parse line. I think this is a little bit too generic for where we are. So I don't know what state we're in. Text is empty. We're expecting, and we get EOF, which is correct. What if we don't do this? Same thing. Unsurprisingly. Operation requires space after increment. So this says, so what can this be? So this can be, it can be this, except it can't be this anymore. So it'd have to be optional. I mean, in this case, required. This would also have to be required. We want to do multiple of those. But it can also have space plus here to be something like this. So that's why you're expecting a plus, or like a space. You are expecting a space or a wa? What? That doesn't make any sense. You're expecting it from this. That's why you're expecting it from that. Oh no, okay, no. This makes sense because we don't have a rule for a single operator. This is what I don't understand. Why are you still continuing? Because it's not like you have, this is not plus, right? It's not a plus. Expecting space y got EOF. So it clearly is able to parse past that, but then it's expecting more. And I don't know why it's expecting that, because increments requires an A. But it's not looking for an A, it's looking for either a space or a Y. Which means it's trying to parse this bit. What? Parser error. Well, this one won't work because we don't have a single one. Maybe that's a hint, actually. Is that a hint? Because in the single case, you're expecting one, which is sure. No, that doesn't make any sense though, because why are you expecting a wa without a space first? Because if we have this is a space plus, the next token should be a space. The next token should be a space. So why are you expecting a wa? It does have something to do with this conflict here. Operation plus repetition, 0 look ahead, space A, space EOF A. Why are you expecting EOF A? No, it definitely has something to do with this conflict. I don't know what to do with this though. Reduced by rule operations, operation rep, and then repetitions plus. Repetitions plus. Okay. That has something small to do with it, I guess. Something small to do with that. But this doesn't actually make much sense, does it? That doesn't explain this. We had this working earlier. So we're expecting a space wa.eof. In what state do you get caught in so that you expect both space and wa? Because that is what doesn't make sense to me. Oh, I see. It's because of this. This is why you're expecting space, because you're at the end here, you have decrements, you expect a bunch of was. So you're either expecting a continuation of this, or you're expecting a space for the next operation. But then why aren't you expecting another A? Because it could be that too. Okay, so let's comment this out. So your operations can either be empty, or it can be a bunch of increment. What? Okay, that doesn't make sense to me at all. Oh, a single space token here. Got pluses. This one isn't even being used. Let's comment that out just in case it matters. Nope. And CL? Nope. Can't remember what the shortcut here is, but we'll go with that. Okay, so apparently that doesn't matter, which makes sense because it's not even being used. Expecting space wa got EOF. Which, yeah, I want you to get EOF. We removed this, which shouldn't also matter because we weren't even using this. How do you... How do we do that? Oh, that's not going to help either. Because this ends up being undefined for some reason. As we found out before. Wait, what? Sponsor.log $3. This doesn't make any sense to me. Because it's undefined. Which means it's not matching this. At all. So why are you not matching? Well, I suppose that was worth a shot. What if we don't do this? What if we change it to be this instead? And then we have a wa here being a an A or a W followed by an A. Changing our approach here. I don't think this one actually matters. So actually I can probably say wa. Sure. Okay. So now we've changed our approach. I don't think this changes anything though. But it might. You're not parse choice and grammar. Why? What are you missing? Because you need a semicolon here. And again, I closed it. Gotta stop doing that. Doris. Awa to BF. Unrecognized text. Not surprising. Try again. Expecting a W space got EOF, which is the same thing as we had before. Makes sense, because all we did was split it out. We're gonna revert that. That doesn't actually change anything. We still end up with this problem here. Alright, it's been a little bit over 2 hours. Maybe we go for a little bit more and then can't get it by then, and this is going to have to go to part 3. Maybe do a little bit of research off stream. No, operations, increments, operation requires space after increment. The next token should be a space. Well, how is it finding the wa? Because you have empty, so operations can be empty. Or operations could be this thing, again. In which case we don't have this. So the next thing that it should be finding is either an EOF, which isn't even included, or it should be finding an A, which is the exact opposite of what I'm seeing here. Because what I would expect is that after it finds this, it's either looking for another wa to complete it, it looks for an EOF to complete the rest of the operations, or it's finding an A so that it can find the next increment. So where are you finding that? Space plus decrements? Space star decrements? star isn't supposed to help us there because it has to have this space. What if we only put a single space then? No, it's still going to the end. Okay, so that's not helping. What if we just put a single Y here? Very simple rule. Like that. And you don't even get that. How? What if we do that? So it requires you to get that. I feel like we introduced a rule and we're forgetting that the rule exists somewhere. But all the rules that we have here, we have operations, EOF. Sure. Operations can be empty. This is hidden. Operations can be increments. Operation requires space after increment. Sure. Then we have no other rules until we get here, where it can be a space and the decrements. And then we commented this one out. And we have the increment and decrement. Where it repeats the 1 and then the 2. And there's nothing up here, so we ignore the leading spaces, trailing spaces. It's all during lexing, which means we don't even touch this here. And then anything else we return to space. I was expecting a space wa. Okay, this makes sense because it's a single one. You add a space, and you get a wa. And then for some reason it just doesn't. Is it because you're expecting a space? Is that what it is? Is this regex wrong? Surely not. But okay, if we remove this, just to say, if it is anything that's not an A or a W, or if it is a space, then we return space. And we'll even just remove this entirely. That is really weird. It should be airing out on this F. Because we aren't accounting for that at all. Do I have the patterns wrong? Is that what that is? Your anchor only at the beginning of the line, which just starting to scan and right after new line has been scanned. An R, but only start condition S. See below for discussion of start conditions. Start condition can only occur at the beginning of pattern. What does that mean? What other start conditions are there other than the caret? It's a negated character class. Yes. I think there's something wrong with this lexer. It's gotta be. Because it should be erroring at those F's, but it's not. The next question is, am I doing this correctly? Am I in the right folder? Yes, otherwise it'd error out. 2158, okay, so that is actually updating properly. So maybe it isn't a problem with the lexer. Although I have a suspicion it might be because those F's are not, like, it should error out at those F's, I think. Maybe it shouldn't, I don't know. But even then, it should recognize that as a space with this in place. Also, I don't know why Vim isn't telling me that this has been updated, which is also pretty suspicious. Or Git tells me it's changed, which is correct. Symbols. Error, program operations, EOF increments. Well, there was one example in the JSON docs that's had something to do with errors, so maybe we can look at that. Error handling. Debug. Oh. There's debug stuff. Okay. What if we turn on debug? I don't know if it's going to do anything, but it's worth a shot. Might already be on debug mode, actually. What are you doing? Yeah, because these are the debug tables, right? Yeah, probably, because if we turn this to 0, we probably won't get those output. Or not. line is a line or new line or epsilon. Epsilon. Bison epsilon. Epsilon is the empty string. But why? You make it empty. Okay. Sure. I'm gonna read the parser to throw away the old look ahead symbol after an error, put y clear in. And recognition action associated with the error symbol y clear in is macro that expands the code that discards the look ahead symbol. Like that. Interesting. Error only. Lex return -1. Sure. Reduce conflict. I wonder if this isn't context free. Surely, no, like awafudge has to be context free, right? Are we looking at? Is it? It can't be context sensitive. Production rules constraints. Near the context-free grammar generates the context-free languages defined by rules of the form A to alpha, with A being non-terminal and alpha being a string of terminals and or non-terminals. The languages are exactly all languages can be recognized by non-deterministic pushdown automaton context-free languages, or rather its subset of deterministic context-free languages, are the theoretical basis for the pure phrase structure of most programming languages. Though their syntax also includes context-sensitive name resolution due to declarations and scope. Often a subset of grammars is used to make parsing easier, such as by an LL parser. Whereas context-sensitive ones are these, where you have a context going to some other context, which we don't have. I don't think we require context-sensitive grammar. Because what are our examples here? Union, intersection, context-sensitive grammar, language example. Consider following context-sensitive grammar. A, B, sure. Maybe it is. No, you can't. Surely awafudge is not context sensitive. I think it makes it easier if we write it in a context sensitive way. I don't think it has to be. Because context sensitive means that we can write something like what is it, like increments and then operations, which goes to something like increments, and then base decrements or something like that. It basically allows us to expand something like this, and I think it might make it easier to do so, but I don't think we need it. That said, do we have access to an LL parser? It also has a special mode for generating LL parse tables. So in theory, yes. Look ahead, left to right, rightmost derivation. But maybe we don't want LALR, we maybe want something different. Maybe we want LR. Oh, but LR1 is not currently practical. We have LR0, but I think we do need to look ahead. So that's not going to help. So the simple LR parser, the SLR. Small parse table is relatively simple parser generator. SLR is quite efficient at finding a single correct bottom-up parse. For example, grammar can be parsed by an SLR but not by an LR0 parser as the following. The right recursive one. SLR grammars. Grammar which is ambiguous will have unavoidable shift-reduce conflicts or reduce-reduce conflicts for every LR analysis method, including SLR. Common way for computer language grammars to be ambiguous if it is if some non-terminal is both left and right recursive, such as that. Which is fine. I think we don't have that. Any reducible rule A, the XB in state S, where X is some terminal, there must not exist some irreducible rule B to A in the same state S, such that the follow sets B. I can't be it. So we have LL grammars available to us. Leftmost derivation. But surely we don't need that. Look ahead, left to right, rightmost derivation. Which means it's all left recursive. Okay. So if we say that... Maybe I'm approaching this wrong, actually. Because if it's going to be left recursive, then we should be building this out from the right side. Which means... starting with the ones that... So for example, we have operations decrements. And if we say we assume this requires spaces, always. One concat 2. Or 3 in this case. Now we can only accept was, but with spaces in front. But of course it's not going to work because we have this here. So we do this instead. Star. Well, of course not. But at least it recognizes it. We changed it. It's not quite what you want. So you have increments, and then you have decrements, always with a space, one or more spaces. You concatenate the third. What if we just do that? Use the name instead. But why? What makes this different? It was working earlier. So I know this is recognized. So you should see increments. So empty and then increments and then space and decrements according to this. Right? You have all these spaces. You have this space and then it has that. $1.concat. So empty is always going to be at the beginning. And then you have operations. $1.concat decrements. Creates a new array. Assigns that to $. And then the next one is going to be $1.concat at 2. And then what? Really, this isn't necessary. Well, I get that. Oh, no, that makes sense, because we're on that side. But if we do it on this side, dollar decrements should include something. But it doesn't. Why are you not recognizing that? It isn't even recognizing that. Is it because of this? It only recognizes part of the word. I think that might be it, because I need the Lexer to consume the next token, or like the next word, next character, but it's not doing that. Easy keyword rules has been turned on. Section, you'll notice the token foo will match whole word only, while using foo will match foo anywhere else unless. Can we turn this off? Can we turn this off? Vanilla JSON will work as if you implicitly specified in every Lexer clause. But I think I am using the vanilla JSON because JSON from npm, which is what we're using, is using the Zach version, which has it on all the time. Ah. Sounds like a bad idea. Okay, hack. Do this. And we're gonna end up having to do this anyway for case insensitivity later. You're not even there. Why are you not showing up? Okay, so we console log this. One.length. Console.log $1. Surely something will come out of this one. No? You don't recognize that? Console.log increments $2. Surely we'll see that. We do. So it's not recognizing decrements? That seems pretty weird. Is it because it's seeing this and it's still going for, must be it. That must be it. Why do you do that? How do I tell it not to do that? Because I need it not to do that. Okay. There's either wa or a string of was. We do this manually instead of doing that. $1 dot at $2. Okay. Now we have that. And then $2 dot length we can still keep. And then we also have was here. Okay. So maybe this is a quirk of the plus. Do not parse JSON grammar, because you need a semicolon. And I close it again. And again. One of these days I'll get it right. One, two, three, four, five. It's still seeing 5. It should not be seeing 5. Dyson, why are you like this? What do you need? Am I using Alexa wrong? Do you have options for the Alexa? Can I get documentation for what options you'd support? I don't know why the redirect isn't going in place. Definitions. Digits. Pattern. Flex 6. Next. Get a character class will match a new line unless that. Rule can have at most one instance of trailing context. Note that the first of these can be written foobar. The following results in dollar or caret beat. Not quite what we're looking for. It's doing the easy keyword rules. Can we look at something? Alright, where are you? Install. This is not the fork that we're looking at. Okay, so the problem is that it's still... We have the increments, and we have the was going across this barrier here, the spaces. We don't want it to do that. So I think we can revert this. For now, we're going to revert that as well. Now we know what the issue is. Now I just got to figure out what this is doing and why it's doing that. I need the scanner to be by custom scanners. You don't have to use built-in JSON lexical scanner. Object lex and set input function would suffice. Which I don't have to write my own lexer. Tracking locations. Up state. String. Let's stop begin string. If you use %x instead of s to declare your start condition, then only rules that match current start condition will be considered. Use the push state. Maintains a start condition stack. It is advised to use more recent Lexer API methods. And this. Begin, expect, console log. Pattern matches, meta characters. Exact string patterns must be placed in quotes. Is it a Lexer problem or is it a parser problem? I have a feeling that it's probably a Lexer problem. This is what's happening. Must be. Okay, so we remove this. Because it was working. We just ignored all the... Okay. So it's a Lexer problem because we did something with this. And something to do with that caused it to fail? Somehow. Is it really just an order issue? So maybe we can't do this in Lex. Okay, so we spent all that time trying to do that, which I think, oh well. So this should take care of that. There are conflicts. We have more conflicts. Why? Right, because it can have multiple decrements like that. Which is not what you want. So is it the same? We do the same thing as we did in the last one, where we handle it in Lex and then try to parse it out with this? Sure, hope not. But also, this is wrong. Or actually, do we care? You know what? All the space nonsense might not matter. Because it's all greedy anyway. Okay. Maybe it doesn't matter. Because it is also all pretty greedy. The other way works too. Look at all these pluses here. And we get minuses. We got more minuses. Alright, this somehow still works. Okay. Well, spent all that time trying to get that to work, and it turns out that we didn't even need to deal with that. For now. Because we do have the issue of it being ambiguous. What if we add the rest of it? So, we don't need this. We just do that. And we don't need this. And it's the same thing, we get a bunch of conflicts. Which is mostly fine. Okay, so we can probably start with that. Okay, so we can commit this. This all good? I think so. Git commit am translate awa and wa to plus and minus. Sure. Okay, so we're going to fill in the rest of this, and after that we're probably going to end it there. We have left shifts plus $1. And we also have right shifts plus $1 as well. Left shifts is a wa plus and then a tilde. Return a tilde. This is that. Repeats $1 length, and it's going to be the same thing for the right shifts, but instead of this, do that, and this also requires another and that'll be $2. Okay. Then we have a look at this. Nice. Because of course. Expecting EOF base wa got tilde. We might, because we do have an ambiguous grammar, we might want to consider recognizing them first. Because of course you have to. And then now we can't recognize the other one. What if we define this first? Which it should matter, because that's not what it says. That's not what it's expecting. Expecting that got EOF. I really hope this isn't context sensitive. It shouldn't be. It better not be. Do I want to try to figure this out now, or do we leave it for later? Because I get it. I know why it would be ambiguous. Still on? I don't know that's a thing. That's what I thought. I'm not sure how to resolve this. Or is it that? No, it wouldn't matter because you're still waiting for. No, that doesn't make any sense. Even if you do this, better not be context sensitive. Okay, so what do we have as conflicts? Decrements, look aheads, EOF space, wa. Conflict in grammar, multiple actions possible, and look ahead token is y in state 10. Sure, that's fine. Reduced by rule, left shifts and decrements, get a wa. Because you don't know at the just with a look ahead like that, like a single look ahead, you don't know if it's going to be a bunch of Ys and then followed by that, or if it's not going to be followed by that. I wonder if it is context sensitive. Surely not. What if I don't think this is going to change anything. But it's worth a shot. No, this isn't quite right. This is, I think I do want... No, I do want this. I do want that. This is still going to be ambiguous, I think. Need a semicolon. Did it again. Ah, but somehow we reduced all the conflicts. But this... Wow. Okay, interesting. Just by adding another rule, we... Ha! That's interesting. I didn't expect that. Which means we add another awa. Is awa plus. And then this is plus $2. I don't know how this helps, but well, I figured it didn't. Actually, somehow we got fewer conflicts when we didn't do that. I don't understand, but okay. What if we did this? And we still only get one conflict. Was repetition plus 0, shift token, then go to state 17. States with conflict, state 12. Was repetition plus 0, look ahead stat. Repetition plus 0, while look ahead stat. Okay. Well, I think that's okay to keep though. That is not okay. This should be 1. It should be 1. Nope. You know what? That seems to work. And I think we have this available to us. And we also have this available to us. And we still have the non... or not. Actually, the W. That's fine. Okay, well that works. Let's commit that. Okay. So now the other, well, the was it the this and that should be all both be pretty simple. Return that. Return that. Read and write. One. So this one should be pretty simple. Yeah, okay. I'd call that good enough. This is recognize, and that's okay. So now for the loop. The loop should be fairly simple. We take this, return that. And we take this, return that. And then this is a loop, just like we have in the other one. And a loop is our compound operation, where we have this operations and then that. In which case, we will translate that to that, And then operations. I'll make that 2. And then plus this. Now operations is an array, which means we can dot join that, and then we should be able to get that. Okay. Missing semicolon. Once again. Source awa. Get conflict, sure. That all still works. Wa. Look at that. And then technically, the grammar allows us to have floating characters like that, but that's okay. I think that works. I think we're still missing a couple of things from this grammar, but for now, I think we can leave that as is. Recognize and yeah, so we're still missing a couple of things. So things like awas can potentially be empty. And if that's the case, then we actually end up with nothing. So it's either just a or a was. In which case, I hope that doesn't... Oh, of course it does. But that allows us to do something like that. In which case, this is equals empty string. Yes. And that's what you would expect to happen. Okay. So that is possible, but just a plain missing just a tilde by itself is not valid. Which seems a little bit asymmetric, but I think that's okay. Allow empty was for our type operations. Okay. I think we might still be missing things, but I think we are good for today. It has been 200 minutes. I think that ends up being a little over 3 hours now. So again, half of this stream was fighting with Jason, but we got there in the end. I have the link to the repo linked in the description for this video, for the stream. I'm gonna push this up right now, or no, I'll do it a little bit after the stream. I need to get my password. Or I can just get my password now. But actually, that puts me at risk of accidentally pasting it for you to see, so maybe not. Yeah, I'll push this up after the stream, You can have a look at it if you want. Next time we do this, which won't be next week, we are going to maybe fix up whatever we need to fix up here, and then maybe get it published on a web page, and then do something creative with it. If you're in the Discord, there is a spoiler link in the programming channel on what I have planned for that. If you're not in the Discord, the link is also in the description. You should join. But yeah, no more streams for the rest of the week. I have to keep my the next few days free. And then next week will also be a bit of a lighter day, or a lighter week, because I happen to be on call at work, and I don't want any potential calls to be interrupting. And I know that if I stream, I'm probably going to be interrupted, and if I don't stream, I won't be. So I'd rather just not take the risk. So yeah, that'll be no streams next week from Wednesday to Wednesday. So I think the only time I might be able to stream is Tuesday. We'll see. We'll see. Which means schedule will probably be out a little earlier than Monday if I can get it. If I can get it together. If I can figure out what I want to stream. Maybe chess. We'll see. But yeah, this is awafudge. We now have a working transpiler. We don't have tests. We should have tests. Maybe we'll do tests for the next one as well. But yeah, that's it. Thanks for staying for the 3 hours, for those of you who stayed the entire time. I know this was a little bit painful for me, and it may have been the same for you, but maybe you learned something along the way. I probably did. I don't know what I ended up learning here. But yes, this is once again, no, I think I got rid of it. I'm gonna show that thumbnail again. But yes, very relevant. And hopefully the next stream won't be so much like this. But yes. Yeah, we'll leave it at that. Thanks for staying. Thanks for watching. See you next stream, whenever that is. I'll put out the schedule sometime in the next few days. But other than that, yeah, thanks for coming, and good night, chat. See you next stream.